the saddest dog sigh in the background.
At your house?
Yes.
Oh. Um, we are live, in theory.
Excellent.
Um, Harry M is asking, what do you guys think about SN8? I watched it live.
I'm still
I
giggling.
know, it was so great.
Like, it didn't fail any of the places I thought it was gonna fail. There were so many
That
times
was
where I
on
was
my
like, "Oh,
list.
it's gonna go, it's gonna go,"
Yeah, yeah.
and it
Should it be on fire the way it is on the inside?
right.
Engines are turning off. Was this planned? It's just
Yes.
falling. That's not flying. Yeah. Yeah.
And to see it like almost make it back down to the ground, and then that was the most spectacular of
Yeah.
explosions.
It's
It
funny. I mean, I 100% agree with you that when you listed off the ways that it could have failed
yes.
and like taking off with 3 Raptor engines, that, I was fully expecting it to just explode. Um, Going up to a high altitude with the rockets firing continuously, I was expecting one or some of them to go off and for it to just crash out in the ocean.
Yeah.
And then for it to perform that complicated flip maneuver and then successfully belly flop, I was expecting it to tumble.
I was expecting destruction
Yeah,
at that
yeah, I was
point.
expecting it
That
to
was
just-
where I thought
yeah.
it was going to die.
It was going to tumble and it was going to
Yeah.
just kind of unravel. It just like there'd be steel rings raining down Boca Chica. But the part that if you think there's any part of this process that SpaceX has nailed, it's the landings.
Right.
But we understand why it
Yes.
failed.
It combusted its own engine.
Well, but the header tank.
Right.
Yeah.
But the green was because it was combusting its own tank.
Or was it its own engine? It was lighting its own engine on
yes.
fire. Yeah.
Yes.
Yeah. Yeah.
And you're not supposed to burn your engine. You're supposed to burn your fuel. But
Oh, burn the
Yeah.
fuel.
right.
Don't
right.
burn the engine. Write that down.
So there was not quite enough pressure, and I'm wondering if they started their engines at too low an altitude.
No. So what happened is Starship has 2 fuel systems. It has the main fuel system for the launch, which is like the big tanks that fill up most of it. But the problem is that when it's doing this sideways maneuver, the fuel inside the tank sits sideways.
Yeah.
And so it can't be, and then when it flips over to do this maneuver, the fuel then sloshes around inside that big tank. And so they couldn't depend on that as a fuel system. So it has a second header tank up at the very top of the rocket, which is highly pressurized, which it can then deliver fuel down to the engines at the last
Right.
minute, and that's its only purpose is to deliver that fuel, uses that for its landing, and it's safe. And the problem was they didn't have the right amount of pressure built into that top tank.
Okay.
And so that's why it failed, is it was trying to get fuel out the engines, wasn't enough pressure, they couldn't provide enough thrust, and it just went
It was spectacular.
crunch.
It was-
Yeah.
So my poor husband, I migrate where I'm working in our house depending on where it's warm and sunny in the house. And I was working in the living room directly below his office when that was happening. And I was on the CosmoQuest Discord chatting with a whole bunch of people as we all watched. We both had like Das Valdez's feed up and SpaceX's feed up, and we're chatting.
Yeah.
And he's like, I couldn't figure out why you were playing video games in the middle of the day. Because it sounded like it was a very loud Kerbal adventure or something. The way I was like, oh, it's going to go. It's going to do. No, it didn't. And
Yeah.
so apparently when I'm watching people blow things up in Kerbal Spaceflight, it sounds the same as when I'm watching SpaceX.
Yeah. And when it was coming down, that was the craziest thing I've ever seen in spaceflight.
It was like those wings are so small. How does that work?
Yeah. Yeah.
It was awesome. It was, It gave me hope that his timelines aren't as insane as I had previously thought they were.
Um, hmm.
I
I
said as insane. I
yeah.
didn't say they were accurate.
Yeah, I mean there's just like I still feel like there's just this one brick wall that has to be overcome. And that is the return from orbit and a safe landing. That's everything.
Yeah.
And hopefully they'll test. I mean, I'm sure they won't, but hopefully they'll test with longer and longer hops. Like they'll fly from Boca Chica to maybe South Africa or something. Like try a multi-kilometer hop where you're over the ocean the whole time, or try a hop to the Canary Islands, something where you're over the ocean and then you just land on the surface and then you test the deceleration capability.
Yeah. So there you're starting to get suborbital. And
Yeah,
um, even the suborbital people usually come back to where they landed.
they just
Thinking
go
of,
up. Yeah,
yeah, thinking of like the original X1 flights, that may be the wrong airplane
yeah.
number. The tests that Virgin Galactic has done. I mean, yeah, I'm not quite sure what the correct combination of places is.
Yeah.
Um, it's a pity that Florida is between Boca Chico and Canaveral because that would be ideal. Just go
Yeah.
land in their own facility in Florida.
Yeah, that'd be amazing. So it's just like that. Like that is up until this point. Can you make? I never doubted. People are like, oh, Fraser was so skeptical. No, no, I've never doubted that they could fly this thing up and
Grain
down.
silo.
Yeah, they could fly this grain silo up and down. The part that I'm not, it's not like that I'm even skeptical. I just think it's going to be harder than they think. I think that they're going to try to bring it back through the atmosphere and it's going to come apart. They're going to bring it through the atmosphere and its wings are going to tear off. They're going to bring it back through the atmosphere and hot gas is going to find some opening and
They
cause
don't
it to come
have a
apart.
heat shield.
It has a heat shield. It has so one half of it is going to be painted with a ceramic that
Okay.
is a heat shield, but it's not
Okay.
ablative. So it'll be reusable. It's a reusable heat shield. And then the other half has no heat shield. So that's it. Landing is one thing. Coming back from 28,000 kilometers per hour is a whole other thing. And my guess is that's where we're going to spend a long time with them trying to solve that problem. But I mean, they're the rocket
I am
scientists, not me.
really looking forward to SN9 and because
Yeah.
they're probably going to get much closer. I'm hoping that they get to the leg day problems with SN9 where it comes down and just falls over.
Right. Right. I mean, they've already tested that the legs work. But SN9 apparently fell over. I don't know if you saw it.
No.
Well, not fell over, but it tilted over in the bay. So
So
speaking of leg problems,
are
you have a dog.
sorry, dog. Dog.
Yeah.
Hi dog. Very excited dog. So was it damaged?
I don't know how much damage. I just saw some pictures on Twitter this morning. I don't know how damaged it was, but
Okay.
it can't be a good thing.
No.
It's sort of shoved over, like it's sort of sitting sideways or leaned over inside the bay.
Oh no.
Yeah. Yeah. So
Oh no.
so a leg failed or two legs failed and so that's gonna need to be a fix. But who knows how much damage was done to it. And even if apparently no damage was done, there could be damage inside. But I
Yeah.
mean SN10 is almost ready. SN11 it's coming. So they've got so many of these prototypes in the works.
Now, are they still building at both Florida and Boca Chico, or are they okay?
Yeah.
Because we haven't seen any of the SN Cape Canaveral stuff yet.
No, I don't think we haven't seen any tests. It's all been done down in Boca Chica, but they are building stuff at both sites. And for a while there, they were sort of racing them.
Yeah.
Yeah. And then of course, then the next step is to build the actual Super Heavy. And I think the Super Heavy is going to be relatively straightforward. I mean, you just stack it high with more Raptor engines firing at the same time, but it's not going to go into that high velocity flight profile.
So let me make sure I'm getting this correct. The current plan is you can go from the surface of the planet to wherever the heck you feel like it with Starship atop a Super Heavy.
Mhm.
It lands on whatever the heck it is, takes back off the way we saw it take off from Boca Chico, and then lands.
Yes.
Now my question is, can they fly just the Starship to LEO?
No, it's not quite enough to go
Okay.
Leo. It needs the booster, but it
Okay.
can do suborbital, so it can probably go halfway across the planet. I think the range is something like 8,000, 9,000 kilometers. So it
So this
can.
could be an express flight for 100 people.
Yeah, yeah. Although you'd still want to shoot it with a super heavy.
Yeah. Okay.
And it can't go to say the moon without a refueling. Like it can't do like the moon and back without a refueling. So what will happen? What most flights will look like when it's delivering Starlinks, it'll be a Starship on top of a Super Heavy. It'll fly to orbit, releases Starlinks. Super Heavy will land. Starship will land, refill it, send it again. And if you're going to go to the moon, then it launches, goes into orbit, meets with a tanker, gets fully refueled, and then goes to the moon, lands on the moon, and then takes off from the moon again and returns to Earth. And if you go to Mars, same thing. You refuel it, you go to Mars, land on Mars, and then refuel it on Mars, and then come back home.
So does this mean that they're nominally going to have to use starships that just stay on Mars to take fuel initially?
Well, they're going to build the fuel on Mars.
I still sense there's going to be a starship at some point that does not come home. And I have a very big dog that just
Oh,
decided for the first time ever to climb into my lap.
I'm sure there'll be ones that don't come home, but they'll be for all kinds of reasons. But no, I think you're going to see these starships coming and going like I don't know, like locomotives. Right? It's not going to be just the debris that we see today. It's going to be yeah, you're gonna oh, we got Starship 41 has got a pretty good orbital trajectory. We can shift its trajectory and have it come by and refuel and pick up this cargo and take it over there. Yeah, it's going to be a different world.
It's going to be exciting, and I'm really going to enjoy the outtakes. And to those of you who are watching, the dog that just climbed up on me is Malachi, who has never done this before, ever.
Aw.
He's a rescue, and he's had a very hard life, and he's occasionally climbed up on my ottoman, but my ottoman is not attached to the chair right now. He just plain climbed up into my lap, which is why I'm not pushing him off, because
You want to encourage this.
this is the dog that like is still learning how to dog.
Yep.
So
Is he whining a little bit?
that's Stella in the background who has
Oh.
a tennis ball.
Yeah, okay. All right. Someone's noting the fur. The shedding must be a sight to behold in shedding
Oh.
season.
I have 3 of these.
Yeah, I know.
This is the medium. They come in small, medium, and large. There's 120 pounds altogether of Australian Shepherd. And his fur is also the medium fur. So their sizes are small, medium, large. Eddie, who's the largest, has a full double coat of 4-inch long hair. This is Malachi, who has 3-inch hair and not
Yeah.
a lot of an undercoat. And Stella doesn't really have an undercoat.
Yeah. Is it funny to you? Sorry to
No, it's all right.
refocus onto space things here.
Yes, you should.
Did you see the coverage of the SpaceX test as it was handled in various places? It was very interesting to see.
Yeah.
Like the BBC totally panned it, called it a failure.
So for me, and I screen captured it, the piece de la resistance was at the end of the SpaceX feed, and I'm going to open it up so I quote it correctly. They're showing a image of the exploded site.
Yeah.
Carnage everywhere, where they have correctly landed on the landing pad where they're supposed to and then gone boom.
Yeah.
And it says T plus 642. Awesome test. Congrats, Starship team! Exclamation mark. And so, like, for what it rocked. And I think everyone in the know understood that. And the problem is that a lot of places no longer have science journalists. Mm-hmm. And if you don't have a science journalist, they're not going to understand how hard this is.
And how wonderful it was.
Yes. Yes, it really, really was.
It really was. That every difficult problem demonstrated that it worked on the first go.
Yeah.
And that a problem that's relatively straightforward for them to solve was a thing that failed. And so well, and they have been having problems with that head pressure the entire time. They've blown up a bunch of starships testing, trying to reach various levels of pressure. Yeah.
Yeah.
Yeah. But still, I mean, it's so funny. Yeah. From our perspective, it was fantastic. It was so great. I've never been so inspired for the future of space exploration of a new rocket system than to watch that thing after watching that thing explode.
And the fact that slushing engine fuel is a real problem they have to solve.
Yeah.
That's kind of amazing.
Yeah.
Yeah.
These. Yeah. Yeah. No, it was
awesome.
It was perfect. I was so excited, and the end was,
it was fabulous.
It was fantastic. It was great to see it explode in the end. It's just sort of like just to see the carnage, but you're like, oh, it does suck.
The fact that all of our expectations were so low.
Yeah.
Like even Musk said there was only a 30% chance of success.
Yeah.
And this is one of the things that I think SpaceX does right that a lot of the other companies don't even do, which is iterative design where failure is going to happen often. When you try and design everything in one go and get everything right the first time, you don't have that chance to innovate as you go.
Yeah.
To figure out where the mistakes are and fix them. And Musk's team is like, okay, if we blow things up, that's fine. Let's just keep trying.
Yeah. This was SN8.
Yes.
SNs 1 through 7 are in various stages of rapid.
They're part of the Texas landscape.
A RUD. Yeah, they're part of the Texas. That's exactly it. And it's going to be a while before they sort this out. But they're doing it in public, as fast as they can.
Yeah.
Everybody's watching as they do this.
Yeah, and that's another one of the amazing things is the location they're at. They can't hide anything from a long lens.
Yeah. Yeah.
Texas is flat and doesn't have the trees Canaveral has.
Yeah. Look at that dog. Your dog is so happy.
I know,
his eyes are rolling back in his head.
He has finally discovered humans are good. Humans are good. I like this.
This is okay.
So rescue dogs, people. When I first rescued this dog, he wouldn't come near any of us. He was afraid of everyone. He bit our instro. But now I have a happy dog.
Good. All right, we should focus on our job.
We should.
Okay. So for those of you wondering what you've stumbled into, this is the Starship and Border Collie?
Australian Shepherd,
right. Starship and Shepherd, a show. But we're also going to record an episode of Astronomy Cast.
Yeah.
So, we'll take about half an hour, and then we'll come back around and we'll answer some more questions about space and or astronomy.
Yep.
Or dogs.
Okay.
Or starships.
All right. So,
let me know when you're ready.
I am ready to press record. I have pressed record. It is recording.
I am also recording. Here we go. Astronomy Cast, episode 588, Lava Tubes. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
I'm doing good. It was, we talked about this on the pre-show. Just a reminder to everybody that we record these shows live every Friday at noon Pacific on YouTube, and the shows are an hour long. So if you want to see more of the witty banter between Pamela and myself, if you want to see Pamela answer completely random questions from whoever's watching the show, then you're going to want to watch that. And so the big piece of news that happened this week was the Starship. And so I think we spent about 20 minutes talking about Starship. But for those of you who missed it, SpaceX tested Starship, and it was magnificent.
Can you hear me?
Yeah.
Sorry,
Are you
Rich.
battling
Okay.
with your audio? Okay.
I have a cable that is getting replaced as soon as the Amazon guy brings a new cable,
Okay.
and I inhaled wrong.
Okay. So where I ended was the flight was magnificent.
I'm still giggling. I don't know when I'm going to stop giggling, but that was the kind of goodness and light I needed in my life.
Yeah, it was a beautiful test. Every part of it went way beyond my expectations. The part where it failed, where it crashed on the landing pad, was the part that surprised me, because I thought the landing was the part that SpaceX had nailed, but all the other parts that were all brand new, all worked perfectly according to plan. So I can't wait to see what happens next.
I would say they worked nominally. I would not say they worked perfectly.
Nominally. Yeah. If ever there was a time for that word.
Yeah, with rockets, all you need is nominal. You do not need exceptional. You just need nominal. But there was that moment where, like, the side of the inside of the rocket caught fire for no obvious reason. There was a great deal more smoke sometimes than others. It went nominally, which is good enough.
Yeah. All right. Well, all eyes are on the moon. We're going back, this time to stay, right? One of the best resources on the moon will be the lava tubes that crisscross the subsurface of the moon. These can provide protection from space and a look at the geologic history of the moon, and they can be enormous. Now, I think before we get on with the show, I think I need to remind everybody that I'm Canadian. I'm not pronouncing the word lava wrong. It's how we say it. So if you're going to send an email and say, man, every time I heard Fraser say the word lava, it was so wrong. Let me tell you why. Pasta, lava, llama. I'll do this all day. So.
And what do you call the really old, tightly bound together star clusters?
Well, that is my own personal accent, globular clusters. But yeah, if you talk to some Canadians, that's the way they say that long A sound. Anyway, and it's never been made more clear to me than by my Texan wife, who giggles every time I say lava. So, but there you go. So I'm aware that I have a Canadian accent. It's an accent. It's like, if I spoke with an English accent or an Australian accent. This is a Canadian
do like
accent.
the Canadian way of saying lava. It does bring me joy.
So let's talk about it. So what is a lava tube?
Okay, so the basic idea is you have some source on a world, pick a world, any world will do, where a weakness in the crust for one of many, many reasons allows liquid rock from deeper down in the world to erupt through the surface. And for these purposes, ice is a rock. And as that stuff flows across the surface, which is presumed to be at a colder temperature than wherever the stuff originated inside the world, the surface of that stuff will solidify, allowing what's underneath it to continue flowing. Here on
Right.
Earth, we have basaltic lava tubes associated with various shield volcanoes. Hawaii has a ton of these. And with basaltic lava flows and related lava tubes, um, you have this highly flowy, liquidy lava that is going across the world, going across Hawaii in this case, and its surface cools off so that you could even walk across it, and underneath the lava just keeps flowing. And eventually the volcano turns off,
Hmm.
the lava keeps going, and it will end up forming a solid structure somewhere, but behind it, it leaves the tube that it flowed through.
It's amazing because when it's done, like because the stuff is flowing so quickly, and depending on what it's made of, it's like a river that has built this roof over top of itself, and then
Yes.
it just keeps flowing, and as you said, ends up in some great deposit out on some plain, and it empties the tube out, and so
And
it's just sitting there as a big empty tube on the surface of the moon or Earth.
and the only thing that really limits the size on these things is gravity. So you have the same problem that structural engineers have, that you can only have so large of a freestanding ceiling before the ceiling runs the risk of collapsing because it doesn't have enough structural integrity to hold itself up.
Right.
We can increase the size using domes and arches here on the Earth, but lava flows really don't get that complicated.
Yeah.
They just kind of flow and have the ceiling. And so here on Earth, you can get them so that they're a few meters to maybe a tens of meters
Yeah.
across, but no bigger than that. However, the moon has much less gravity. And so you can end up with lava tubes that are hundreds of meters in
Yeah.
all directions, big enough. These are no longer so much lava tubes as lava empty caverns you can build a city in.
Yeah, you could put a city, like the biggest city on Earth, the tallest towers on Earth. You could put them inside some of these tubes, and they would fit no problem. That's
Yes.
how big these things are. Have you ever been in a lava tube?
No, I've seen entrances to them.
Yeah.
Now, most of them that you'll see in Hawaii have signs on them that say, do not enter. And then the next set of words is some combination of rock is really sharp, danger of collapse,
Right.
both of those things.
Right.
And this is actually one of the major issues for exploration of lava tubes on the moon and Mars. Basalts, basaltic lava is really, really sharp. This is the black stuff that you can sometimes buy at a gardening store to use as edging.
Yeah.
And if you handle it without gloves, you can end up inadvertently shredding your hands
Yeah.
on the sharp, unweathered edges.
Yeah.
Now, the stuff that you buy for your garden has been tumbled around, has collided with one another, has been rained on at some point, and it's still that sharp. You don't have rain on the moon, and presumably nothing has gone rolling around inside one of these tubes, potentially knocking down the sharp edges.
We'll get to that in the risk portion in a second. I've been in two. So the one was in Hawaii, and
Uh-huh.
I ignored those signs and went right in. No problem. But the other one that I was in, it was in Oregon at the Lava Tubes Monument in Oregon.
Oh,
And
I
it's
didn't know about that.
just phenomenal. Just absolutely amazing. It's like a subway. It's like you're walking in a subway. But you definitely see chunks of rock on the ground that fell from the ceiling. But
Yeah.
it is amazing how and it is smooth. The walls are like, it all just depends on the composition of the lava. And so in Hawaii you get that stuff, which is like
Right.
crumbly glass that rolls on the surface. But if it's of a different composition, then it goes more quickly, and it can be a lot smoother. So then, so we've got these gigantic chasms. How do we know that they're there? on the moon?
Well, two different ways. One is assumptions, which are generally not the best things to make, but with science, we don't always have the robots we need to go out and touch things. What we see on the moon are these sinuous rills, these weird features that look like someone splatted an earthworm or a long, skinny snake on the surface of the moon. And they'll often have a series of crushed places along their length. What we think these are is lava tubes that are partially collapsed. And this pattern of sinuous structure and collapsed regions matches some of the lava tubes we see here on Earth. Now, the other more exciting thing that we've seen are what are called skylights. And one of the cool things about the lava rooms, I'm going to call them on the moon, is you can have essentially a floodplain that lava goes across. And it creates this large flat structure with a cavern underneath. And they have found circular cave ins that we call skylights, for lack of a better word. Um, in one case, one of these was 80 meters across. So the hole into the chamber was bigger than the diameter of your typical lava tube here on Earth.
That's crazy. And so you've got this. The pictures are wonderful.
Yeah.
Do a search for lunar skylights or moon skylights, and you'll get a chance to see them. They are these black holes on the
Yeah.
surface of the moon. So it's all regular lunar regolith with craters and all that kind of stuff. And then there are these black gaps. And in some cases, you can even see like the illumination of the floor below. But
Yes.
so it's just a chunk of moon that's caved in.
So the skylight in the Sea of Tranquility appears to be based on the shadows that we see changing from orbit to orbit of the Lunar Reconnaissance Orbiter. It appears to be 100 meters deep. That's like taking a football field, turning it sideways, and the length of the football field is the vertical depth of this
Right.
cavern.
And it's not like I think you need to stop using cavern because it's not like a dome. It is
Just flat.
dozens,
It just has a
hundreds of
flat.
kilometers long. Like it is just
Well,
this
that's
giant
yes.
open cylinder that or half cylinder that just goes on forever for a very long distance. And
Yeah.
you're just seeing one little entrance into this.
Yes.
Okay, so this is how we find them. Why are they so valuable for space exploration?
Three basic reasons. The first is space likes to throw rocks. And here on Earth, as anyone who goes out to see the Geminids next week will notice, space likes to throw rocks at the Earth. And as these pebbles, dust grains, tiny rocks hit the Earth's atmosphere, they generally burn up or at least get heated enough that they explode into small pieces that generally don't cause harm. Generally, occasionally, really big things cause harm. But that rain of pebbles and dust and grains of sand and pea-sized rocks, all of that stuff we don't have to worry about because of our atmosphere. The moon doesn't have an atmosphere. Mars has much less atmosphere. This means that there is a much greater risk of all that shrapnel hitting us if we're what's on the moon or Mars. By going underground, you have a naturally built protection from falling rocks in the form of lava rock. So you use rocks to protect yourself from rocks,
Yeah.
which works.
Yeah, totally.
The other issue is radiation. The universe is trying to kill us. This is a recurring theme in this show. And the moon is outside of any protection that the Earth's magnetic field could possibly provide. And the moon doesn't really have its own intrinsic strong magnetic field. It just has patchy magnetism here and there. That doesn't do you any good. So, by going underground, the thickness of that lava can protect you from the high energy particles, the high energy photons, cosmic rays, all that stuff is going to get stopped by that depth of rock.
So you're protected from falling rock, except for the rock that could be falling inside the, but we'll talk
It's
about that in
true.
the risks portion of this conversation. You're protected from the radiation, and that stuff is bad.
Yeah.
Like you are, I think you're 200 times, you experience 200 times more radiation standing on the surface of the moon than you would inside one of these lava tubes. So just getting even a few inches of rock between you and space makes all the difference on whether or not you're going to take a solar flare in the face or
Right.
or have an increased risk of cancer when you get back from your mission.
And I just feel the need to point out that I fear for the astronauts for the planned lunar missions that are planned as we go towards solar max. Solar max is not when I would do a return trip to the moon, but I know the calendar and the technological developments don't always line up.
Right.
So the other thing that's useful about this is it's thought that various resources will be easier to access. So, for instance, if there are any pockets of water as opposed to just water mixed into the mineralogy of the moon, inside one of
Hmm.
these permanently shadowed caverns would be a good place to get it.
So could you? I mean, there are these permanently shadowed regions at the poles of the moon, but
Yes.
is it thought that you could have like little ice deposits inside these tubes?
It's unknown, but this falls into the category of things that are improbable and perfectly allowed by science. Because the temperatures inside, you're not being hit by sunlight, it's going to stay cold, so volatiles are not going to be disrupted. So, if there was a comet that struck once upon a time, its materials could survive, but the question is, how did they get in there with lava? So it's unknown, but there's the potential for easier access to resources. Now, on Mars, I mean, on the moon, this is probably not something that's actually going to be relevant. There's the potential, but it's a low probability. On Mars, where there's subsurface water that we already think is there, getting underground could put us into a significantly more habitable ecosystem where you have access to water, you have protection from radiation. And this is definitely a good place to go looking for life, which also means that's the last place we should send people.
Right. And unless we want to find cyanobacteria everywhere we go. But so you've got like this, but you definitely have a geologic history
Yes.
in sort of the same way that a crater digs out material, you're going to have material building up around the lava tube that you can then look at and explore.
And this is actually one of the things that's going to make exploration that much harder because lava tubes aren't nice, smooth rock on the inside. They are sharp, lumpy, not healthy for most robots. And there's efforts being made here on Earth to develop robots that are capable of navigating the terrain without shredding themselves. But because you have to be underground, you can't rely on solar, and any cables that you might drag behind you for communications purposes are going to get shredded unless they're super protected, in which case you now are dragging behind you really heavy cable,
Hmm.
or you're basically pooping out radio relays as you go, which is another option for robots.
Yep.
But either way, it's going to require a lot of technological development that we just don't have yet.
So let's talk about this then. I mean, what plans have been put in place or have been thought through to explore them? Like you talked about some of the challenges, but what would a mission to a lava tube kind of look like?
So the earliest ideas that are likely to fly, some of the Google Lunar X Prize teams had plans to have little itty bitty tiny robots, which means they don't weigh very much and the gravity's already pretty low. And the idea was for them to essentially dangle themselves down, lower themselves into the tube, and just give it a good look around. So here, just a good old handy dandy, big wheeled, works upside down and sideways robot. It's all you really need. For something larger, there's consideration of how do you build something that has 300 feet of cable it can drag behind it?
Yeah.
And there's folks trying to figure out how to do that here on Earth and develop the techniques needed to.
Yeah, there's the team from the European Space Agency. They have the Caves program
Mhm.
where they are testing out exploration methods in lava tubes in Europe. I'm not sure where they're operating out of, but they've got wonderful pictures. They're some of my favorite pictures.
Spain's Canary Islands is
Yeah,
where a lot of this work is being done. And so this is the European Space Agency. They've developed various rover prototypes. One of my favorite things about their prototypes is their wheels look like starfish rolling along. They have that slightly curved starfish in the wind look to them because that gives them better traction as they go. And by working in Earth's younger, more protected environments, they get things that aren't weathered as much as they might be in other places.
right, right. Um, there was a mission. There's been a couple of mission concepts that have gone through the NIAC program,
Yeah.
and a couple that are fairly recent. This is the NASA's Advanced Innovative Concepts program. I'm a huge fan of these. Many of the stories we cover on Universe Today are this, and so one was a mission that would send a kind of like a drone to one of these the lava tube skylights and scan above it for a while. They would essentially like fire like a lunar lander, and it would just sort of propel itself around, taking pictures in high level lidar of the whole area, and then a spelunking craft that would lower itself down in it and take pictures, as you said. The other thing that's kind of interesting is this idea of rovers that can kind of change their shape depending
Yeah.
on the structure of what it is that they're rolling over, because the surfaces of the tubes at the bottom are actually they're very rough, and they can have huge boulders, and it's a very complicated environment to roll around in. So you could have a rover that could actually change its body shape depending on what kind of terrain it's rolling over top of. But it seems like it's everything we need. If you want to live on the moon, it's the perfect place.
And the only issue that it's going to be annoying to try and solve is the cheapest, easiest way to build habitats is inflatables. But building an inflatable in what is essentially a spiky glass shardy cave,
Right.
it's really a good way to destroy your inflatable. And a lot of these shape changing robots are also doing it by inflating themselves into different kinds of shape. So this is really going to be a cool challenge for material scientists to develop that highly flexible Kevlar essentially that will allow it to take a beating with sharp shreddy glass and not spring a leak.
And so when you look at that picture, for those of you who hopefully you've now Googled lunar skylight, and you'll see sort of the classic example. You get the sunlit portion that is in sunlight. And so you could have solar panels that are
Yeah.
in that sunlit portion, but you can be outside of in the darker portion, away from the radiation. So that would work. So let's talk about the risks then. What are the challenges to if you do have a crew of astronauts down there in a lava tube? What kind of risks are they going to face?
Well, I mean, it's the same risks that we have with caving here on Earth, just much harder to deal with. So here on Earth, when you're caving, you always have to worry about getting stuck in a tight space, about cutting yourself, about how do you drop down into a cave that you enter through a pit above. And so the initial issue is going to be how do we safely belay robots or humans through a skylight. I mean, this is really Mission Impossible
Yeah.
stuff here. Get to the bottom of the cave. We don't know how smooth or lumpy it's going to be because we're going in where there was a cave in, people. Um, Figure out how to create a path out of the rubble pile at the bottom of this thing you've just belayed into, and then go off and in the complete darkness of the tube work on creating illumination and building a safe habitat somehow. Now, you also have to worry about, well, if a big enough space rock hits above you, that could trigger a cave in. And so it's one thing to build a habitat that can be quickly mended, can be self healing when it gets punctured, but what do you deal with when that rock, and instead of exploding one room on your habitat, has just caved in the wall, the ceiling of your
Right.
habitat?
Well, and
So
there's no terminal velocity on the moon because it's a
right.
vacuum. And
Yeah.
so here on Earth, if a small rock falls, it'll hit terminal velocity for whatever its shape is, and then it'll stop falling. Like it's literally, if you drop you can have a small rock dropped on you from pretty much any height, and it's not going to hurt you that badly. But you can imagine boulders, they're going to fall a kilometer and just accelerate the entire way and then smash into your habitat. So you need to be
Yeah.
building that.
Yeah. Yeah. It's it's something where we need to build better robots to figure a lot of this out. And one of the things that is a bit disturbing is because human life on Earth costs so little, we haven't already developed these robots for mining purposes. And so once we have the kinds of robots that can very readily go into these kinds of environments, it's going to basically make it so that we don't need miners going after diamonds, miners going after coal, because we'll have robots that can fill those roles. So it's the we can't do it already because human life is cheap, but once we can do it, we're going to be unemploying people. And so that is like ethical conundrum of the I don't know what to do with this information, and this is why I'm an astronomer.
Right. Well, I mean, the challenge of machines replacing humans is one as old as time, and the way that works out
Yeah.
is the machines replace humans. That's
Yes,
how that ends every time.
it's true.
But I mean, I think people are kind of imagining that you would fill the tube with air and then try to live in there, but no, like this is like you're gonna have a little pup tent at the
Yeah.
bottom of the lava tube that you're gonna live inside. You're not
Yeah.
going to be trying to seal it. I wonder if you could. Like,
Yes.
could
Yeah.
you seal, like if you could fix the skylight or pick a different part of it and seal that up?
Yeah.
Could you then pressurize the interior and turn it into a
Yes.
wow? Okay.
And you'd have to coat the sides, but this is where you start imagining the under city, the under river boring machines that we already have, that as they bore will line the cave that they're boring with cement or some other polymer of some sort. Where here what we're looking at is we just need a robot to polymer the inside of it so that it's completely sealed. And there's again more robots, please.
Yeah, 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 absolutely. It's a fascinating idea, and again, I highly recommend that you search for the ESA Caves project because they are
Yes.
really pioneering just every aspect of this, both human and robotic exploration of lava tubes on Earth, but imagining what it would be like as astronauts attempting to do it. And it's a fascinating idea to think about. And it's like the best worst place. It's if the moon is the worst place, then lava tube is the best part of the worst place.
And there's some let me start that sentence over. There are some adorable Google Lunar X Prize plans for exploring some of these with tiny add-on robots that drop on tethers and
Yeah.
things like that.
Yeah, not gonna lie, I have devoted a ton of my journalist career reporting on lava tubes and both human and robotic, and I'm tickled by the idea, and I just think it's so great, and it really feels like you will see people living in lava tubes once, you know.
So I have one question that you may know the answer to. The word spelunking gets used to describe going into these caves, and I had always thought that spelunking was reserved for caving in water, and that is not the case. So
So,
why do we call it spelunking to go caving on the moon or Mars?
oh, I have no idea.
Okay.
Yeah.
These are the open questions
There you
we
go.
discover
So,
doing
so,
Astronomy
so
Cast.
instead of writing an email about my Canadian accent, write us an email explaining why spelunking is a term, and maybe what you would call it if it was on the moon or Mars. Would it be spelunking?
Yes.
Or because if moon dirt is called regolith because it's not actually dirt, it's ground up rock,
Yeah.
is there a different term for going
It's
into a
caving.
cave?
You're going
You're
caving. I'm
caving,
just going to
yeah.
stick with
All right.
that.
All right, Pamela, that was awesome. Do you have some names for us this week?
I do. As always, we are supported thanks to the generous contributions of people like you. It's a rough year for a lot of people, and I cannot tell you how grateful we are to those who are still doing okay and have shared the fact that they're doing okay with us through their contributions. Um, we are part of a tax deductible nonprofit, which means that if you donate now, it will help you with your 2020 taxes. So if you're doing okay and you need a tax write off, think of us. And one of the best ways that you can donate is through patreon.com/astronomycast. And this week, I would like to thank our patrons, Catherine McCabe, Jeanette Wink, Emily Patterson, Div, Grad, Curl, and all that. I'd love science. Helga Bjorkog, Gordon Dewey, Sinai, Joshua Pearson, Bill Hamilton, Frank Trippin, Richard Riviera, Alexis, Jake Mudge, Thomas Stepstrup, William Andrews, um, Jeff Collins, Harold Bardenhagen, Ben Floss, Merrick Vidarni, and Arctic Fox. Thank you to all of you for everything that you've given that allows us to do all the things we do.
Thank you, everybody. And Pamela, we'll see you next week.
See you later. Bye-bye. And now we save.
And they saved.
So Stella kicked Malachi off and then promptly fell asleep on top of me. I have no idea why he suddenly climbed. Oh, there she goes. I have no idea why he suddenly climbed up like that, but he was like, I want attention right now. So
That's so
apologies. Cute. But when the rescue dog that has never done that before, I didn't have the heart to boot the rescue dog.
No one is gonna. I was gonna explain for a moment what the panting sound. Like, if people are like hearing that, they're like, "Wait, what?" But I mean, I think people know that your life is dogs.
Yes, it is.
All right, I'm gonna break all the rules and I'm gonna upload.
Okay.
While we're talking, because I have so much internet.
I'm living dangerously and adjusting my mic.
Okay.
There.
We'll see if I've got a faster machine now, so we'll see if I have any hiccups. Let me know if I drop any frames or lose anything. Well, we've got like five minutes left to talk about it. So here we go. Really quick questions. You ready?
Okay.
Bonus lightning round. Janelle Duncan, if you reflect light using mirrors and lava tubes, would it be safe?
Yes.
Akba Halsey, how stable would the edge of a skylight be?
Unknown. It depends on the skylight.
Would it be possible, I think Hal McKinney was asking this, would it be possible to smooth out the floor of a lava tube with road construction? Yes.
Yes.
Let's see. There's questions that we answered.
Let me see if there's anything I can see on Twitch.
Okay, Hal McKinney also asks, are lava tubes mostly near the moon and the Earth's surface, or do the tubes exist all the way down to the total lava layer?
They're mostly near the surface because that allows the cooling that takes place. They radiate the heat away, and that allows the surface to solidify.
Kirov99, how energetic is the Australian Shepherd breed?
It's super, super energetic. They need a job. They would really like a herd of sheep. Failing that, they would like to play agility, to play fetch. They just want to go, 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 go. When the weather is nice and plagues are less, I'll actually go bike riding with a dog. I have a special shock absorber bar that keeps the dog away from the bicycle. And
Like a leash?
there's a metal tube that has shock absorbers inside of it that goes at a right angle off of the seat post and keeps the dog 3 feet away from the bike so that they won't get in the tires.
Right.
And then there's a leash on that that drops down to where the dog is. So, and the shock absorbers are necessary in case of squirrel or Eddie will try and run down other bicyclists, and I've clocked him going 12 miles per hour.
So the dog will pull, and so I guess it's pulling, as opposed to it pulling your wheel sideways, it's pulling you from the sideways on the seat, which is a little more, you can handle that a little better.
Yeah, and because of the springs in the shock absorber, it spreads the time of it out.
Right.
And so instead of that instantaneous yank, it's something that you can react to. And I have to take them on a bike. I tried doing the 0 to 5K zombie app, figuring, I'll get in shape with Eddie. And he pulled out of my hand and caught a bicyclist.
Right.
So that was when I realized.
You know what that means? That means you're the monster.
Yes.
You're the monster that's chasing other people. You're the zombie.
Yeah.
Larry Beckham wanted to know, can Starship reach Sydney by itself? Does it need a booster?
It should be able to, but let's not do that until it works better.
Yeah. No cargo. Like, I think originally the plan was Starship could be Leo with no cargo. Like, if it was completely stripped down, it could just make orbit with more engines. I think it needs 6, 7. So but they're gonna have different variants depending on what it needs to do. There'll be ones with only vacuum engines that never come through the Earth's atmosphere. So Larry Beckham chain. Also, I mean when it does not explode anymore. Yeah, exactly. Yeah. All right. Escalax asked, if we could directly measure the distance to a galaxy at the edge of the observable universe using parallax or a standard candle, what would we measure? 14 billion light years?
So we couldn't do it with parallax.
Sure, but let's say that we could. Or would we measure 45 billion light years? I mean, I guess what Escalax is asking is, we know that the actual distance to the objects in the cosmic microwave background radiation, for example, is 45 billion light years away because of their movement and the expansion of the universe, not the 14 billion years that the light has been traveling. Right. So if we used parallax to measure an object there, what distance would we find?
It would be the 14.
Yeah. Yeah, because all you can do is measure the light, and the light has been traveling for 14. And so it would appear to be 14. All right. I think we've reached the end of our hour. Okay. That was fun. I like hitting you with the quick questions. It's good.
Yeah.
We should do that sometimes. Although it's also fun to really grind on a question too. So, what's the next thing that's happening from the Cosmic Quest Empire that people should take part in?
Oh man, we have so much stuff going on. We just come join us on Discord. That's really the best thing you can do. There's a link on cosmoquest.org. We have conversations. We have shared watch parties of various launches. And of course, as always, we have the daily space running Tuesdays through Fridays. uh, right here on twitch.tv/CosmoQuestX. And it's hosted by Beth Johnson, Annie Wilson, and I. And we bring you a fast paced rundown, and then you can go read things in detail over on Universe Today.
I like that. I like that site. What did I do? I'm working on my newsletter right now, so hopefully that'll go out in a couple of hours. So if you haven't already got it, universetoday.com/newsletter. I just interviewed Elizabeth Howell, who's a
Oh, yeah.
Canadian journalist, space journalist, and has focused a lot. She just wrote a book on the history of Canadian space exploration. So if you want to learn more about that, we talked about that. Hopefully a virtual star party on Saturday.
Oh,
We're going to
good.
start an hour earlier, so I think we're starting at 6 this time around.
Did you see any of the solar storm yesterday?
No cloud here.
Okay.
Yeah. Maybe the sun's going to come out today. I don't know. And then we are building up. We are going to try to live stream the conjunction. So
Oh,
stay
excellent.
tuned for that. That'll be on the 21st.
Yes.
Okay. Well, thank you everybody for joining us. Thanks to all the moderators. Thanks to Nancy Graziano, of course, for herding all the cats. And thank you, Pamela, for bringing the brain. And we'll see all of you next week. Thanks, everybody.
Bye, everyone.